Okay, we're going to take a look at projectile motion for AS Physics for Excel. AS projectile motion is a lot like Angry Birds. By that I mean the description of the flight path that projectiles take. Because we ignore air resistance, we get these perfect parabolas every time, whereas what would actually happen with air resistance is the flight path would be a lot shorter, as kinetic energy would be lost into the surroundings as pushing the air particles out of the way. So it would actually be a bit shorter. So we ignore air resistance at AS projectile motion. So here's how we go about solving projectile motion question. First of all, you draw a basic diagram so you can figure out what's going on. And objects projected at an angle are no use to us because we know that horizontal and vertical motions are independent of each other. So if there's any angles involved, you need to resolve the vectors into purely horizontal and vertical motions. A bit of trig and a bit of Pythagoras for that. And then it always helps to draw out a SUVAT table for horizontal x and vertical y motions. Then you can keep track of all the values you figured out and figure out what equations to use. After that, you've got your equations on the physics sheet for the exams. The only one that's missing there is displacement equals velocity times time. You fill in the values you have and use a bit of algebra to solve the equations. So we have a problem here. An angry bird is projected at an angle of 40 degrees to the horizontal at a velocity of 12 meters per second. So you need to figure out what is its maximum vertical displacement and his maximal horizontal displacement. I say his, it may be a lady, I don't know. So here's our first problem, and we draw our basic diagram and our SUVAT table. We know that the initial velocity was an angle is positive, therefore gravity, the acceleration due to g will be downwards, will be negative. So I won't worry too much about the minus symbols too much just now. I mean, it will be pretty obvious if something's gone wrong. All these problems should make sense as well. Physics is like the rules to the universe. So if you end up with velocities of millions and millions of meters per second or times that just seem far too long for a projectile, you'll recognise it pretty quickly. So we've got to solve maximum vertical displacement. So how much up does it have? Now, I've drawn another basic diagram so I can use a little bit of trigonometry to solve the components. So for the horizontal velocity, the initial velocity is cos 40 times 12, which gives us initial horizontal velocity of 9.19, and vertically it's sine 40, which gives us 7.71. Now, put these in the SUVAT table. Now we need 3 values in any one column in order to solve the problems using our equation, so we're looking for something else. Now, if we make the assumption that something at the top of its peak, so if you throw a ball up, when it gets to the top of its peak, it should be travelling vertically at 0 meters per second. It should be for a fraction of a second, not have any velocity. So, if we use that in our SUVAT table, that gives us 3 as the magic number, which seems to fit with this okay. So we write down our equation, we populate our equation, and then we solve using algebra, and that gives us a displacement of 3.03 meters. So that's how high the angry bird gets. Now what we need to do is figure out the horizontal displacement. So we have from before our SUVAT table plus all the values we have. Now what I'm going to do is I'm going to figure out the time that it takes to go up. I'm doing this because it takes a certain amount of time to get up, it'll take the same amount of time to go down. So if I can figure out the amount of time it takes to reach the top of its peak, which is 3.03 meters, then I can figure out, by timesing that by 2, the total time before it hits again. So, I'm going to use this equation here, substitute in everything I know so far, and that gives me a time of 0.79 seconds to get to the peak. Now, that's to get to the top. It'll take the same amount of time to fall down again, so all I'll do is simply times that by 2, and then the time to travel, the total displacement, will be 1.58 seconds. I've already got my initial horizontal velocity, so it's simply a matter of velocity times time, which gives us 14.52 meters per second. Not so hard after all.